once again, hello everyone. Now we'll go with the second session of the same chapter, that is Introduction to Intel x86 family. Okay, in the first session we have studied about the comparisons of different microprocessors. In this we will study about two important things, that is flag of x86 as well as memory mapping of 16-bit and 32-bit. Okay, I think this topic is about programming model. Okay, so programming model of 32-bit and 16-bit. Now programming model, in the sense, I think we have seen different types of registers. Here also you can see it is divided into three parts. Can you see general purpose registers, segment registers, and instruction pointer and flag. Okay, now this diagram is about 32-bit programming model. Okay, can you see here 0, and here you can see 31. So 0 to 31, that means it is 32, and it is divided into three sections. Remember very important things. In the 16-bit model also you will be getting this almost the same diagram, but only difference will be some data segments will be more, and this stack segment and data segment is 16-bit. So very important difference between this two diagram is whether it is 32-bit programming model or whether it is 16-bit programming model. This is always this section, that is data segment and stack segment, is always 16-bit. Okay, now let's go to the next slide. Whatever the diagram we have seen, they have just given the explanation of that. The 8086 defines the base of the programming model of entire x86. So the model of x86, whatever the program, remember one more thing, the 32-bit version is also of 386, 486 and Pentium. So it is applicable for all the microprocessors. So the new members of x86 families have greater computing powers because they are faster. They use 32-bit registers instead of 16-bit registers and have advanced addressing techniques. A programming model of 32-bit version of x86 family consists of three groups, as I was telling you when I started this session. Now the first group contains 8 general purpose registers. We call them as EAX, EBX, ECXD, EDX, ECI, ESI, then EDI, ESP and EBP, where E tells us that these registers have extended length. Each registers can address in 1, 8, 16 or 32-bit models. When you look at the diagram, I think you can see all this. I think here I can see, here we are having 0 to 7, then 15, 16 and then, so it has been, it can be divided into 16-bit till here and then again 16, so total it becomes 32-bit. Okay, now after this, the second group of registers is the segment group, consists of code segment, stack segment and 4 data segment registers. The data segment registers are DS, ES, FS and GS. Now remember that in the first group you are having only 8 general purpose registers. Second group we have, as they were telling, some 4 data segment registers and others are segment registers. So these are 16-bit registers. These manage the operations of external memory, address computations and data movements are performed here. So remember that whatever the address you want to calculate, that can be done here, or whatever the computations, data movements, whatever you want to do, that is performed in the second group. The third set of registers consist of instruction pointer and the flag register. Okay, I think that also we have seen in the diagram. Now what we'll do is we'll be going with the 16 bit. That was about, I think it comes for 3 to 4 marks. The diagram is almost same, but only change will be in the size. The size is 16 bit and there will be some less registers in this. Okay, the 8088 and 8086 defines the base programming model of x86. It is used by 16 bit. It is divided into three register groups. The first group contains 8 general purpose registers called A's, A, B, C, D, SI, DI, SP, BP. Then we also have AL, BL, where L indicates lower byte and H indicates higher bytes. The full 16-bit registers are referred as AX, BX, CX and DX, where X stands for extended. SI, DI, BP, SP registers are always treated as 16-bit registers. These registers are pointer register because they are used to point to locations within the segment. We will see the diagram of that also. The second group of registers is the segment group, consists of code segment, stack segment and 4 data segment registers. These manage operations with external memory, address computations and data movement are performed here. As I was telling you that it is almost the same 16-bit what do you call, the middle group of registers, that is data segment and segment registers are same. The third group consists of instruction pointer and flag registers. So this is a diagram of 16-bit register. When you look at this diagram, can you see we are having some general purpose registers. One minute. We are having some general purpose registers. Then we are having segment registers, and at the end we are having instruction pointer and flag registers. Okay, and when you compare this diagram with this I think diagram is almost same, but here you can see some less number of registers, but rest of the things, only size difference is there. Okay, but rest of the things are same. So if they ask the question about 16-bit, then you have to draw this diagram. Okay, so general purpose registers, segment registers and instruction pointer and flag register. So I hope you understood programming model of 8085. Programming model of 16-bit as well as 32-bit version. One more thing I just want you to tell you, the 16-bit version is applicable only for 8088, 8086 and 286. Now the last concluding topic of this chapter is flag of x86. So this is a flag of x86. Now here you can say that this flag is similar to our 8085 flag. Can you see carry, parity, auxiliary carry, zero, sign? Till here everything is fine. Then we also, it is a 32-bit flag. Can you see till from here 0 to 31? Then yeah, as I was telling you, till here everything is same, but from here, that is T, I, D, O, overflow, then IOPL, that is mixed. 2 places have been given for them. Then NT, RF, VM and AC. So some full forms are given like carry, parity, auxiliary, flag, zero flag, sign flag, trap, interrupt, direction, overflow. Then IOPL stands for input output privilege level, nested task flag, then resume flag, virtual mode and alignment check. And you can also see that in some places they have written 286, 386, 486 like this. That means in that era or in that generation they have been evolved. Okay, now very important thing here is you don't have to remember till 32 or 31. You have to remember the flags till 18 and rest of the flags are reserved. So I hope you understood till here. Now we will have little discussion like 8085 microprocessor was having 8-bit registers 0 to 7 with 5 flags active. 8086 and 88 microprocessor has 16-bit registers. 8 to 11 are introduced and remaining bits were unused. Then 80286 microprocessor is also 16-bit, but 12 to 14 bits were added. Then 80386 microprocessor is 32-bit, 16 and 17 bits were introduced. Then 80486 microprocessor, again 32-bit, with only one one flag has been added, that is 18th bit. Remaining all the positions in the flag are reserved. So I hope this also comes for 3 marks. The question will be like this: draw the flag of x86 family. So I think you have to draw this, you have to write the full forms, and I think I have mentioned in which year which flag was introduced. Okay, so I hope you understood till here everything. I think today we have discussed about programming model of 16-bit and 32-bit and x86 flag. Okay, with this we have concluded this chapter, and we'll meet in the next session. Thank you.